All right, so what we're trying to do here is sketch at least one full cycle of a full-fledged sinusoid. And a sinusoid, remember, is just a wave function. It's either a graph of sine or cosine. And I always want you to graph at least one negative critical value. So this is going to be kind of a spicy one, but I'll talk you through it. Okay, so let's do it. It says f of x is -2 sine of. Ooh, look at the inside, right? You weren't allowed to go inside of a lot of places in DC. A lot of them are verboten, right? Unless you want to kind of scale walls and risk being shot, you know. But the things that you can get inside of are pretty cool. So we're allowed inside of here, but it looks like a discombobulated mess. So the first thing we need to do is put this into a sense of order, right? Standard transformation order. And if there's any work to be done, the most fun work comes on the inside. So the x term needs to come first, and that's already there, right? That looks good. But I need the coefficient of x to be a 1. Otherwise, my horizontal shift, also known as a what shift for wave functions? Horizontal shift is also known as a phase shift, right? I've got to have that be 1. Right now it's negative pi. So remember, what we have to do is I got to factor out that negative pi from both terms. All right, now we put f of x equals, that's the first step. All right, so we got -2 sine of parentheses, negative pi, parentheses, close, -5. All right, now what do you get when you factor out a negative pi from negative pi x? That's pretty easy, right? You're just left with x because we're dividing it out, right? Remember, factoring is dividing out. So what do you get when you factor out a negative pi from a pi halves? A 1? A -1/2? Or a 2? Well, let's see. When in doubt, come off to the side. We're starting with a positive pi halves, and I'm dividing out a negative pi. That's what we're doing. We factor out. Okay, so when you do that off to the side on your workbench, stay, change, flip, stay, change, and then flip. That's really -1 pi over 1. That's -1 over pi. What happens with your pi's? They divide out, and what are we left with? -1/2. Yeah, -1/2. So you've probably said that. Maybe some of y'all said that. Maybe not. But how do we know it's right? Well, we didn't mess up when we did it off to the side, but we can always redistribute and make sure, right? Negative times negative is positive. Pi times 1/2 is pi halves. Okay, so that one wasn't that bad. But we made sure that we got it right because now we're going to use this information for everything else, right? And we don't want to be using wrong information. Even if we're using it correctly, we would like to be accurate. So let's come off to the side here and list the following: A, B, with absolute values around both of them, C, D, P, then R, far. All right, what is A? What's the other name for A? Amplitude, right? And what is it here? It's a 2, okay? So that means that we're going to go up 2 units from the sinusoidal midpoint axis and down 2 units from the sinusoidal midpoint axis. But the fact that it's negative, what does a negative in front of any function do to it? Flips it, right? So I'm just going to put x-axis reflection right here. These are like stage notes to ourselves, okay? Part B or B. What's the absolute value of B? Pi, okay? Now what does the negative mean there? If B is negative, we reflect it across the y-axis, okay? Now, what's the other name for B here? It's not just the horizontal compression. Is this thing going to be pi times wider or pi times narrower? Right, it's opposite. It's not 3.14 times wider, it's 3.14 times narrower. So that's going to make the period or the length of one cycle shorter, yes? So once you find B, you're going to see pi cycles in 2 pi. Okay, so previously where we saw 1 complete cycle from 0 to 2 pi, now we're going to see 3 full ones plus 1.41596 of another one. Now, as soon as you find B, jump down here to P, because remember, P is 2 pi over that number. So let's find the new period. It's 2 pi over pi, which is what? 2. Oh, that's nice, because guess what? I just took pi out of my x-axis. The length of one cycle is 2 units. Oh, that's going to be nice. All right. Now let's look at C. What is C? Well, I'm going to put a colon here instead of equal, because I don't really care if you tell me C is 1/2 or negative 1/2. I want you to interpret it. If it's X minus 1/2, is that going to be right 1/2 or left 1/2? Right 1/2. Right, Rayleigh? Hang in there. I know. I feel the same way. Got in so late last night. And then I slept in a good bed finally for the first time in a week. And then the alarm goes off just as soon as you lay your head down, right? You know the feeling. It's like crap, right? But at least my dogs were happy to see me. I had to play with them for a little bit. What is D? -5, which means down 5, right? So if one of my dogs was named 5 last night when I got home and they were so excited to see me, jumping up, you know, happy with their nails, you'd be like, what? Down 5, down 5. And 5 would be like, I can't, I'm too excited to see you. Everybody in DC has a dog. It's like a status symbol. I think if like you just walk a dog and you can just put a little vest on it and say it's a service dog and you can take it wherever you go. But all the dogs there are well behaved. If I took my dogs to DC, they'd be arrested. You know, they'd be like, this dog is trying to attack the president. It's so, you know, and I'm like, no, it's not. It's just, it's my dog.
Just say down. Actually stands for Dog County.
For what?
Dog County.
Dog County, DC. There you go. Dog County. Yeah, Dog County, Washington. Everyone has a dog. All right.
If I went there with my dogs, JJ would try to pick a fight and then run away. Wiley would go through with the fight.
Yeah.
Mario would just be pacifist.
Yeah. And what would Luigi do?
We don't have.
Oh, yeah. Okay. Bowser. Bowser is a good name. Hey, let's find R. R is the range, right? R sub f, if you will. We can actually find the range of this function before we even graph it, because we know how to graph it, yes? How do we get to the low point? Well, the low point is always from your sinusoidal axis down the amplitude. So for us, let's go ahead and write this as our sinusoidal axis is at -5. That's your D value. And then we're going to go down 2 for the low point. And then the high point is your sinusoidal axis, which is -5. And then we're going to go up 2. So that's how you can find it. I think I might have mentioned this in one of the videos. It's your D value minus the absolute value of A for your low point, and then the D value plus the absolute value of A for your high point. So let's see what that gives us. That gives us -7 to -3. Now, it's important to be able to find that before we graph it, because it'll kind of not only help us answer multiple choice question more quickly on a test, but it kind of helps us when we set up our graph. It looks like y'all got this far on the video, huh? So far? Yeah, it's okay. Does it hurt to see it again? No, it doesn't hurt to see it again. So now what we're going to do, good morning. Now what we're going to do is the following. We're going to say, you know what? This negative B value here, I don't like it. Yeah, I don't like negative B values. Yucky, gross. YYGG. Okay? Or 2y, 2g, y squared, g squared. So here's what we're going to do. We're going to use the symmetry. Always use symmetry to rid a negative B value. We'll write this as a B value less than 0. Always. Because as you probably noticed from already doing this example, a negative A value is not a hard thing to accomplish at the very end. All we have to do is switch the highs and the lows in your shahala, shichala, chala, sahala method. That's easy. But to reflect it across the y-axis, you almost have to graph it first and then physically send it across. It's not as easy. So if we use symmetry, it'll be easy, right? So what do I mean by symmetry? Well, we have 2 types of functions, even or odd. What is sine? Is sine even or odd? Do you remember? Odd, okay? So sine is an odd function. It has origin symmetry. So in general, what that means is f of negative x is the opposite of f of positive x. Opposite inputs give you opposite outputs. So for us, that means sine of negative x is the opposite of sine of positive x. So essentially for us, if we have a negative B value for sine, we don't get rid of it, but we can pull it out front, essentially. Yes? Pull it out front. Pull a negative out front. So let's see what that'll do. If I pull this negative out front, I get f of x equals, well, holy moly smokers, there's already a negative there. Guess what a negative times a negative is? A positive. So, wow, we don't even need to flip it anymore. So now we get pi times x minus a half, close, minus 5. All right. So we don't have to do either of those reflections anymore. That's nice. Now, had the negative not already been out front, the negative would have come out front, and now we would have an x-axis reflection, right? So that's what you do. You either take a b value and you turn it into an x-axis reflection, or what's the other type of function we have? Even function, right? And for an even function, negative inputs are the same as positive inputs. Because of the y-axis symmetry, you're going to get the same output whether you plug in a positive or negative. That's cha law. So cosine of negative x is the same as cosine of positive x. So what do you do with the negative? You forget about it. You forget about it. Forget about it. All right. So for sine, you pull the negative out front. But for cosine, you forget about it. One word. Dog County. I like dog. I like that. Yeah. Okay. So anyway, now what we do, since there is a horizontal shift, is we make our sacrificial rough draft axis. Okay. So here's what we do. We come over here and here's 0. Right. That's your y-axis. And then you come out whatever the period is. What is the period for this one? 2. Okay. And then you bisect it, 1, and you bisect it again. When you bisect something twice, it's like taking a fourth of it. So now you have your quarter cycle counting interval. So you can mark that now halfway between 1 and 2 and just count by half. 1 half, 2 halves. This would be 3 halves. This would be the same as 4 halves, 5 halves, 6 halves. All right. So this is the spacing between each critical value. All right. You can also find it this way. You could say if the period is 2, what's a fourth of the period? Well, it's a fourth of 2, which is 2/4 or 1/2. That's going to continue to be the spacing in between every critical value. Now, what did I do? I picked everything up and moved it what? Right 1/2. Oh, that's easy. Because guess what? 1/2 is already a critical value, yes? So all I really do is I pick up my y-axis. Let me draw my y-axis here as a, well, I pick up my y-axis, which normally was at 0, and I move it now over 1/2 units, which sets it down in the same tracks essentially, right? So this is your new y-axis. So this is still a relatively easy one. You're going to see that if we have new values that aren't like already tracked ruts, we're going to have to relabel it. Okay. So this is easy. Now we can go to our graph over here. So draw yourself a y-axis and an x-axis. Now I'm drawing my x-axis a little bit higher because I know the range. The range is entirely negative. It's from -7 to -3. So here's how you can set up the y-axis. I don't really care about the scale there. Let's just call this -3 and let's call this -7. If you want to do your high and low, get that taken care of. Where would your sinusoidal axis now live in relation to those two? Smack dab in what? The middle, right? So let's draw that as a dotted line, and I'll use Notability for that. That looks good. Move it up a little bit. Nice. Okay, so this is now essentially, this is your new y-axis or x-axis. This is your new x-axis, but we call that the sinusoidal axis. Now, where is that? It's -5, right? So let's label that as -5. Okay, now if you didn't know what that was, like we'll be doing later from the graph, writing the equation, all you have to do is find the midpoint. So the midpoint of two numbers is just their average. How do you find the midpoint of two numbers? You just find their average, right? What's -3 plus -7? -10. What's half of -10? -5. That's the midpoint. Or if you know where the sinusoidal axis is and you know the amplitude is 2, you can go up from there, down from there. So there you go. That takes care of the vertical axis. That's the easier of the two. That's easier too. Okay, thank you. Yeah. All right. Now the fun part, right, Brady? The x-axis. I'm going to go ahead and drop a line at what I'm going to call 1/2, and I'll drop a perp there. I'm going to try and, since I already did my rough draft axis, I know 0 is still going to be a critical value. All right. So I'm just going to drop that line right here. And I'll use, again, notability for that. All right. So about right here. Yeah, it's good enough, right? Good enough. All right. So this is like your new y-axis, but it's your vertical line, x equals 1/2. Okay. Let's call this y equals -5. Let's label this. All right. So now we have our new origin. Now what I'm going to do is I'm going to label my critical values. The distance that I have established here, and this is super important. 0 is also a critical value. This is also a critical value. That distance between those two, as soon as you put 2 critical values down on your paper, you need to preserve that distance the best you can. I'll look for that. So now let's just eyeball it. Okay, there it is. There it is. Whoop, there it is. Whoop, there it is. Whoop, whoop, there it is. Whoop, there it is. And we always have to show at least one negative. So whoop, there it is. Now, you be the judge. Do those all look about the same distance from each other? Thank you very much. Thank you. Thank you very much. And now we just have to label them. This is, of course, 0. And how far apart are they?
1/2.
They're 1/2 away from each other because that's 1/4 of the period. Good. So let's just count 0, 1/2, 2 halves, we simplify, 3 halves, 4 halves, which is 2, 5 halves, 6 halves, 7 halves, 8 halves, so on, so forth. And what is my one negative value? -1/2. Okay. This is now what I call setting the table. The table is all set, right? Now, before we eat, we have to put the food on the plates, I guess, right? The table's set. Now we put the food on the plate. That's putting your dots, okay? So now I'm going to pick a thicker line quality and choose a new flavor. Now we come back up here. What function is this? This is a positive, right? If you look in front, it's positive. So this is a positive Sahala. Positive Sahala. So all I have to do is mark my values for sine, axis high, axis low. Well, guess what? The axis is your new origin. So there's your first point. So now it's axis. We go to the right, high, axis, low, axis, high, axis, low. And then we go back. Is 0 a critical value? Yes, it would be a low point. And then your first, there you go. So now we got the food on the plates. Now it's time to dig in. Let's eat. And eating is connecting these dots. Okay. So it looks something like this. Exaggerate the curve. Don't make them as straight lines. I'll be angry with you. Make them curvy. Remember, the sinusoidal axis is where the curvature changes from concave up like a cup to concave down like a frown. Okay. So make it go from frown to smile, frown to smile. And then always go a little bit past your last values and put a little arrow to show that it continues on and on. And that right there, folks, is a beautiful sinusoid. Okay, now, yeah, thank you, thank you. Now, here's what we're going to do. Thank you very much. This started as a positive sign. That's how we generated the graph. But what we're going to do now is we are going to write several different equations for this function that give the same graph, but are in terms of either negative sign or plus or minus cosine. All right. So here's what we're going to do. Let's go ahead and also say f of x equals. This graph is what it is, right? This graph is what it is. So the amplitude has to be a 2, right? The period has to be, I'm sorry, the amplitude is 2, the period also, right? What was the period? It was also 2, right? That's coincidence. So here's the only thing that's going to change. When you write a new trig function for it, the only thing that might possibly change are the following. The sign out front and the trig function you use. Those are the only two that might change. Okay. Here's why. Let's come up here and I'll show you why. We have positive Sahala, and then we have positive Chala. All right. Now, we don't really have to write plus signs in front of numbers. If we don't write anything in front of a number, we understand that it's positive, yes? Just like Sahala and Chala, but sometimes we can put a plus sign in front. So when I put a plus sign in front of those, I'm talking about the sign of the A value. Now, let's do this. Let's do negative Sahala and negative Chala. You have to do your transformations in order from left to right. So the negative out front has to be one of the first things you do. You reflect it across the x-axis before you shift it up or down, right? Because that's addition. Shifting it up or down is addition, and this is multiplication. Well, remember that the sinusoidal axis always starts on the x-axis. So if you have a negative in front of a sine or a cosine, the way we're going to graph it, it's just going to change the highs and lows. Because if you reflected this graph across the x-axis before you shift it, this point here is going to be down here, and this point is going to be here, and the points that are on the axis would be the same. So here's all you have to do. You just flip your highs and lows. So your axis points stay the same, but now your highs become lows and your lows become sine. And so this is kind of what Brady was saying, oh, so 12, 13 days ago, that you get negative Salaha. That's like the bizarro twin of Sahala. Now, you don't have to memorize negative Salaha so much as what I want you to realize is that if you change the sign in front, all you're doing is flipping the highs and lows. And so what would the bizarro twin for Chala be? Well, the axis points stay the same, but then you change the high to a low and the low to a high and a high to a low, and you get the funniest name of any bizarro twin I've ever encountered, Klahal. You got all these cool superhero names, right? Positive Sahala, positive Chala, negative Salaha, and negative Klahal. I don't know. I just think it's funny. Okay. But hey, don't memorize those two bizarro twin names. Just realize again that there's a negative out front. You flip it across the x-axis. So here's how we're going to write. Oh, here's what else might change. The phase shift. That's probably the most important part. The phase shift has to get to a first letter. Get to a first letter. What do I mean by get to a first letter? That's this here, because by the Sahala and Chala method, we're always starting at the original origin. Okay. So let's go ahead and come down here. Let's go ahead and set up our template. We're going to put a 2, and I'll do a -2 sign. And the B value is going to be the same. It's going to be pi. But now it's going to be x plus or minus something, something minus 5. So this will be writing one in terms of negative sign. Okay. Where do we have to shift in order to get to a negative sign? What are we looking for a negative sign?
It's a negative sign. That means it's Salaha, so we have to move it to the left.
We're looking for an axis point, but you got to be careful.
Yeah.
If you're looking at an axis point, you can go up or down from an axis point, right? We want to be on an axis point going what?
Low.
Right, axis going down.
Yeah, so I mean, you have to move it to -1/2.
Yeah, so where are we on an axis going down? Right here. This would be negative sign right here. Or right here would be negative sign. Or right here would be negative sign. I spy 3 different places on this graph where we're on axes going down. Y'all see them? Yeah. So I can get, all I have to do is shift over to any one of those. And remember, it's the opposite of what I appear. So if I shift over to -1/2, is that going to be plus or minus 1/2? It's going to be plus 1/2, right? That'll take me over to the one on the left. Or let's write the other 2. It could be -2 sine of pi times x plus or minus something, something minus 5. What if I wanted to get over to positive 3/2? Would it be plus or minus 3/2? Minus, right? It's the opposite of what it appears. because it's inside. Or the last one, -2 sine of pi times x plus or minus something something minus 5. If I wanted to get over way over there to 7/2, it would be -7/2. So the phase shift, along with what's out front, are the only things that change. If I ask you to write a negative sign, the B value is going to be the same and the D value is going to be the same. What's going to change? Whether you're flipping it or not, and your phase shift. Okay. So for negative sign, we're always on the axis going down. All right, let's go ahead and write another one for positive cosine. Let's just write one more for positive sine. Sorry. Let's do positive sine. +2 sine pi x plus or minus something something minus 5. So this is kind of how you can do your template. I want to do a positive sign, and now I do x plus or minus something. Well, we already generated this graph from a positive sign, didn't we? When we simplified it, we got x minus 1/2. So this right here was a positive sign, because positive sign is Sahala. That's an axis going up. Does anyone else see another point on this graph that we've made where we're on the axis going up? 5/2. Yeah. How far away is 5/2 from 1/2? It's a full cycle away, isn't it? It's a coterminal angle, if you will. It's a full period away. What's the period? 2, right? Every point that we do, -1/2, +3/2, +7/2, those are all 2 units away. Same thing here. If I want to be positive sign, axis going up, 2 units away, there's another axis going up. So I could also say x minus 5/2. That would be another equation for positive sign. So we have 3 equations for negative sign, and we have another equation for positive sign. You know who's going to feel left out if we don't talk about him? Cosine. So let's go ahead and do this. Let's go ahead and do a cosine. Let's do a positive cosine. So I'll do +2 cosine pi parentheses x plus or minus something minus 5. And we'll set up a negative cosine. F of x is -2 cosine of pi x plus or minus something something minus 5. Again, the only thing that's changing are the trig functions and then the shift. So let's do positive cosine. Positive cosine is Chala, right? Chala. So if you come back over here, we have to be on a high point. Well, that's easy to spot for positive cosine. If you're up top, there's only one place to go from there, right? And that's down. So for sine, you have to be careful because you're on an axis to start with, but you could be going up or down. For cosine, you just look for a high point. Does anyone see a high point on here? Yeah, I see 2 of them. So here's a positive cosine and here's a positive cosine. So as long as I can get over to there as my starting point, I have another equation. So if I wanted to start at 1, would it be x plus or minus 1? Minus. It's opposite of what it appears, right? And if I wanted to get over to 3, it would be what? -3, opposite of what it appears. Hey, how far apart are 1 and 3? 2 units, the period. Don't that amazing? Oh, I did that second one wrong. Yeah, I could say or +2 cosine pi x minus 3. Hey, what would be the next one? We don't even have the graph, but what would be the next place where it's at the high point? 5, right? And then 7, and then 9, so on and so forth. Now, the last one here before the bell rings, negative cosine. Negative cosine. This is easy. Negative cosine starts where? Low. Do we see a low point? Yes. Here's a negative cosine. Here's a negative cosine. Here's a negative cosine. So as long as I can shift over there, well, if I want to do this negative cosine, do I have to shift at all? No, that's at 0, right? So I don't even have to have a shift. You could say x minus 0, or you could just say cosine of pi x, right? Oh, that's the nicest equation out there, isn't it? Because you don't have to have a shift. But you could have negative cosine of pi x plus or minus something minus 5. If you did want to shift it, where's your next low point? It's at 2, so x minus 2. Where would be the next one? X minus 4. And then X minus 6, so on and so forth. So hopefully you understand now that as long as you have one equation, you can sketch the graph. And once you have the graph beautifully set up and organized, you can write an equation now that gives you the same graph in terms of sine or cosine. We did it. Welcome back, everybody. Enjoyed National Math World Experience Day. See y'all tomorrow, 10 and 8. Don't forget 10 and 8.